Welcome back, everyone. We had some pages left in section 2 from chapter 6, and we have two vision conditions. Now we have farsightedness and we have nearsightedness. Normally, this is going to be a normal vision when you don't have any of these conditions. The image is going to be appearing here on the retina. But if you have farsightedness, or another name for that is going to be hyperopia. If you have farsightedness or hyperopia, the image is going to be appearing behind the retina. Normally it should be here, but now as you see, it is here. It's behind the retina. You can recognize it by its name. It's called farsightedness. Means objects that are far appear clearly, but objects that are close appear blurry. Now, let me draw something here. If we have a lens, of course, the lens from our eyes is a converging lens. Eye lens, let's call this eye lens. Now, we have the principal axis, of course. The light rays are going to be what? They are going to be converging at this point, let's say. And let's say this is the retina, okay? Now, what should I do? What should I do to bring back this focal point on the retina? I can do something. I can make the lens, or I can use an object that brings back or that converges these light rays early. Now, the reason that this image is appearing behind the retina is that light rays converge so late. So I'm going to what? I'm going to put a converging lens here on the eye, and then it is going to bring back the focal point or the appearance of the image back to the retina. Now, let me repeat that. Farsightedness or hyperopia is a condition that happens when the image appears behind the retina, and objects that are far appear clearly, but objects that are close appear blurry. How can we correct that? We can correct that by using a converging lens. A lens is basically an object that floats on a flood of tears, okay, in your eye. We have the second one, which is nearsightedness. Nearsightedness, you can recognize it by its name. Near, it means objects that are near or that are close appear very clearly, but objects that are far appear blurry. Now, this is a normal vision. The image appears on the retina, but when you have myopia, which is another name for it, or nearsightedness, or close-sightedness, the image is going to be appearing in front of the retina. That is why you can see objects that are close, but not objects that are far. So, let me draw again something here. So we have a converging lens. This time, we have, let's say this is the retina. The image is appearing here. It means the light rays are converging so early. We need to make them converge late, or we have to put them back their place, which is on the retina. How can we do something like this? We need to spread these rays, and we can do that by what? By using a diverging lens. Now, how can we correct myopia? We can correct myopia by using a diverging lens. Hyperopia, we can solve that, we can correct that by using a converging lens. This, which is called a two-lens system, is used in microscopes and telescopes. It's basically when you have two lenses, the image from the first lens acts as an object to the other lens, which is here, which is called an eyepiece. This is going to act as a magnifier, and then here, this one, we're going to just use it to collect the light rays. And here, this is going to be what? This image here is going to be acting as an object to the second lens. Same thing happens in refracting telescopes too. You basically have an objective lens. It's going to form an image here, And then this image is going to be acting as an object for the eyepiece. This eyepiece is going to magnify the image, and that is how microscopes and telescopes work. In the next video, we're going to solve section review. See you in the next video.